All right, everyone. Thank you for joining us for the IEEE VIS Test-of-Time Awards. The history behind the VIS Test-of-Time Awards, they were started in 2016 by InfoVis, where they provided a 10 and 20-year Test-of-Time Award, and VIS 10-year Test-of-Time Award. In 2017, the community added a 15-year VIS and 25 years VIS Test-of-Time Awards. And our goal is to align all conferences by 2031. There are multiple kind of strange number of year awards given out each year in order to meet this alignment. This year, the VIS 25 Years Awards and the SciVis 13 Years Awards and the SciVis 12 Years Awards are given out by Liz Marai and Eddie Groller. The InfoVis 20-Year Award and InfoVis 10-Year Award will be given out by Helbig Hauser, and the VAS 10-Year Award will be given out by Tobias Schreck. With that, I'll turn it over to Liz for the first award.
Next slide. Hello, everyone. I'm Liz Marai, University of Illinois, Chicago, and together with Edward Groller, Technical University of Vienna, I co-chaired the Visualization Conference Award and the Scientific Visualization Awards this year, Test of Time. We benefited from the help of a committee made of Issei Fujishiro, Luis Gustavo Nonato, and Deborah Silver. And the process we followed, next slide. First, we received sets of 10 to 11 candidate papers from the Visualization Steering Committee, selected based on the number of citations. We identified conflicts of interest, and then each committee member identified 3 candidate papers for each award, and then we met and discussed. Next slide. Following the 5 criteria defined by the steering committee related to impact within the discipline and outside the discipline. Next slide. The winner of the 25 Years VIS Test-of-Time Award goes to, next slide, a paper which introduced a multi-resolution hierarchical clustering solution to the overplotting problem present in parallel coordinate plots. This enabled the interactive visualization of large multivariate datasets, and the enhancements proposed in this paper have been adopted not only in data visualization, but also in data mining and database research. It's an extremely seminal and influential work, the most cited paper from VIS 1999, and it has had a profound and lasting impact on data visualization. Next slide. So this award goes to Hierarchical Parallel Coordinates for Exploration of Large Datasets by Ying-Huey Fua, Matthew Ward, and Elke Rundensteiner, and Elke will be here to accept the award. Next slide.
So I would like to thank the committee for the great honor in getting this award on behalf of my co-authors. To introduce the co-authors, the first co-author, Ying-Huey Fua, was a master thesis student at the time from Singapore, and she currently works at a Polytechnic Institute in Singapore. The second author, Professor Matt Ward, was a colleague at WPI. He's the one who deserves all the recognition for this award. He was the core source of inspiration and of the ideas. And all I can say is that I was blessed to have him as an amazing colleague, as a mentor, and as a research partner from the moment that I arrived at WPI 30 years ago until his passing much too early. He has been an inspiration around everybody that I think he has touched. The visualization community was his home. And if only he could be here now, he would be so pleased. So I want to dedicate this in deep memory to him. You can see some of the photos of students he engaged with, holding babies, leading students to graduation, and what difference he has made. Going forward, next slide, sorry. What problem did we solve? A good research paper requires a problem that matters to you, and that is a practical problem. So we looked at a very simple problem. Parallel coordinates, a very popular technique at that time. And when does it fail? So if you have a small number of data points, they work great. We can find outliers, trends, inverse correlations. But look on the right, when we put up hundreds, thousands of data points, suddenly they become occluded and useless. We can't see anything anymore. We could either throw them away or we can fix this problem. Next slide. And the key of that was, the key insight we had was, if you take every data point and you give it a dedicated visual element on the screen, you're not going to have enough space. Everything will be colluded, and you cannot really use these display techniques anymore. So we had to set out to solve this problem. That's on the next slide. And what we ended up doing is something very simple. We looked at 2 points. One, how can I use machine learning techniques to abstract the data, to reduce from large number of data to small data? And then given this aggregated smaller data, how do we display that at this point? And direct manipulations. So as you see on the slide, for example, we took data mining, data clustering, and took the data points and clustered them up into a smaller number of clusters. And on the left, you see an example of how we then display clusters instead of individual points, looking both at the inside, which is the dark lines, as well as at the bands that tell us whether a cluster is dense or sparse. And we used other visual elements. After we had established this, we looked at which clusters should we display. We could, given that we had a cluster hierarchy, on the left top, you can see we can display the top level cluster, which is a single point representing the whole data set, or we can zoom in and represent lower levels of the data, more and more detail. On the bottom right, you can see we can show individual data points and anything in between. That's led us to the third innovation, which is how do we manipulate this data in a direct manner? And the third innovation was structure-based brushing. Rather than just brushing on the data, can we brush on the abstract space, which is the data cluster hierarchy, to zoom in, drill out, mask, and so on. Altogether, these innovations were all fundamental and simple to grasp, which is the most exciting thing to do, because when you could do simple things, you can take next steps and innovate. So here is a sequence of papers that followed, looking, for example, at how do we take the interactive hierarchical displays and move them to glyphs or other displays, or how do we solve the problem that what if the data had many, many dimensions and we actually needed to manipulate these dimensions because we cannot show anything. In fact, that follow-on work led to a Test-of-Time Award in InfoVis just last year alone by Dr. Jin Yang and other collaborators. So the work has carried on for our own team, as well as I'm grateful it has carried on for many others that have cited this work. So doing simple things can often be an inspiration for doing more and more relaxing based on data is uncertain, data is dynamic, and so on. With this, I would like to close. Receiving this award is the best way to memorize Professor Matt Ward. If he only could be watching us now, he would be so proud, because the visualization community was his research home. That is where he really enjoyed doing research. And if he was here today, he would be giving you these words of wisdom that you see here. Solve real problems. Do whatever you want. Don't be limited by your field itself. Collaborate with others, because that's how you can bring out the best in yourself. So in closing, I would like to thank the award committee, but I also would like to thank the leadership of the VIS community. I don't know how you managed to pull off this conference once, twice, another hurricane, and here you are doing it virtually online, making sure that the community has a place to communicate. So I want to thank the community as a whole for receiving this award, especially on behalf of Professor Matt Ward. Thank you.
So I take over from here. Congratulations, Elke and co-authors for this nice paper. My name is Eddie Gröller from TU Wien, and we are now coming to the 13 years SciVis Test-of-Time Award, and we will see the justification on the next slide. This is a paper that deals with a systematic exploration of high-dimensional parameter spaces as a two-stage process. It's a clever statistical approach with sparse sampling and combined with visual guidance to determine optimal response regions under uncertainty. Parameter space analysis is an ongoing hot topic in our field, and explainability, not only in the context of AI, is still an important open challenge. The impact of the paper is evidenced by the many and recent citations due to the numerous follow-up works, which resulted from the Tuner paper. It is a fine piece of research based on solid theoretical foundations that touches on and integrates several pressing topics in our field, like high dimensionality, parameter spaces, visual guidance, and uncertainty. Stay tuned. Tuner is to stay. So this award goes to the paper on the next slide. A principled parameter finding for image segmentation algorithms using visual response surface exploration. The co-authors are Thomas Torsney-Weir, Ahmed, Saad, Torsten Moller, Hans-Christian Hege, Britta Weber, Jean-Marc Verbavatz, and Stephen Bergner. And I think Torsten and Hans-Christian are here to take the award and give us some words. So go ahead.
Thank you very much, Edi. It's been a humongous honor, and we're humbled by the award. And on behalf of the authors, co-authors, I'm happy to accept it. The inspiration for this work was really coming from working with applications. Especially, we collaborated a lot with people in applied mathematics. And but especially some applications in medicine and biology brought out this over and over again as a really hard problem. But also at that time, rise of machine learning, we're still on the other slide. The rise of machine learning made this problem apparent again. We were inspired, of course, by really fantastic work in the past from the fantastic Chuck von Weyck and Robert van Liere. Their 1993 paper Hyperslice influenced us a lot, but also some fantastic work in the design and analysis of computer experiments by statisticians. Next. Why is it impactful? We believe that there's a good combination of foundational visualization methods and an application addressing a long-standing problem in computational science. It's been there for a long while. I also like to say that, and I tell it also to my students, it helps not to know that a problem is hard. It sort of frees the mind to come up with novel things. You should not take this as a liberty not to read up on the past work. Please do, but still. The proposed method, in my humble opinion, is actually that simple. And that is one of the reasons why it's sometimes not all that easy to get it through the reviewing process and to convince others about it. For instance, one of the reviewers said this is a solid application paper with sufficient details about the applications and its use cases. The weakness of the paper is its lack of novelty. Next. The last thing we want to point out, we actually seriously struggled on where to submit this work because the data that was to be visualized was multidimensional, 5-dimensional, 8-dimensional spaces, and that's a traditional InfoVis kind of realm. It doesn't have a canonical layout. It's really abstract data. It is a SciVis problem because computational science, special medical imaging applications have been traditionally published in SciVis. But at the same time, the tool we developed, Tuner, is really a visual analysis system designed to help an expert better understand the relationship between the inputs and the outputs of a model or an algorithm. And that's really the traditional visual analytics approach. So we're happy in many different ways that our community is overcoming and has overcome this troubling divide. And thank you very much again for honoring us with this award.
So congratulations, Torsten, Hans-Christian, and the other co-authors. We stay tuned. So now we come to the winner of the 12-year SciVis Test-of-Time Award. And this is what is a given because of the following justification on the next slide, which the work proposed a novel method for selecting 3D point clouds using 2D sketches and uses an efficient and intuitive density binning mechanism to define selection surfaces around points chosen with a lasso tool. It's an innovative technique and has significantly influenced the virtual reality community, inspiring the development of various other interaction methods. The technique's impact is evident in its citation in the patent of a commercial product, underscoring the paper's substantial contribution to the field. By bridging the gap between 2D input and 3D data manipulation, this method enhances user interaction and gives a valuable tool for virtual reality applications and beyond that. And so this award goes to the paper, Efficient Structure-Aware Selection Techniques for 3D Point Cloud Visualization with 2 degrees of freedom input. And the authors are Lingyun Yu, Konstantinos, Efstathiou, Petra Isenberg, and Tobias Isenberg. And Lingyun will take the award and give some words to us.
Okay, so on behalf, and previous slide, please. The previous one. Okay, on behalf of Konstantinos and Petra and Tobias, I would like to thank the IEEE VIS conference organizers and the awards committee. So to quickly sum up our work, we focused on the spatial selection techniques for 3D point cloud data visualization. Next slide, please. So rather than selecting a single object, we aim to select dense regions of data, which is the fundamental task for visualization. Selecting data depends on 2 key aspects: identifying where the target is and determining how big the selection range should be. When these 2 are unclear or hard to define, selection becomes challenging. Next slide, please. So the idea started from the discussion with astronomers. We were surprised to find that they were relying on Boolean operation-based approach to select particles. This approach requires multiple rounds of rotation and selection in order to get a result, which is time-consuming and inaccurate. So next slide, please. Cloud Lasso addressed these 2 challenges by helping users identify the depths of the targets in 3D space, something that is not so easy on a 2D screen. Next slide. Next slide. So our technique was inspired by a simple but brilliant 3D geometry technique from the 1999 SIGGRAPH paper, best paper of Teddy. Our method shared a similar concept. We both aim to create a 3D volume based on a 2D input stroke. Next slide, please. So here is how our algorithm works. We first compute a 3D density field for the point cloud data. Then we identify the grid points with densities above a certain threshold. We construct a selection volume using marching cube method and select particles within this volume. We call our method as Cloud Lasso. Next slide, please. This work has sparked many interesting interaction techniques for spatial data. We noticed that users' actions often reflect their selection intention. This insight led us to create many selection techniques in VR, AR, MR, or with hybrid environments. So this method enabled users to select data accurately from any view directions, even when their input is imprecise or incomplete. Next slide, please. What I want to emphasize today is, while visualization guides user interest, it is the interactive techniques that facilitate a comprehensive and deep understanding of data features. When designing interactive techniques for data visualization, we have to consider both user input and data's feature. So we are still exploring these ideas, and I hope this work inspires further innovative and effective approaches in this field. And I would like to thank all my co-authors and everyone involved in this award. Thank you.
So with this, I think we are ready to move on to the InfoVis Test-of-Time Awards. Next slide. I'm presenting them on behalf of a committee consisting of Issei Fujishiro, Ros Maciejewski, and Min Chen. And we worked, next slide, on a process to select 2 Test-of-Time Awards, one for 20 years and one for 10 years at this conference. We were initially given 10 candidate papers for the 20 years award and 6 for the 10 years award. We checked our conflicts of interest. Those were not so many. All in all, we had 2 of them for all committee members, and we took care of them in the remainder of the process. In the first round evaluation, we did an asynchronous offline evaluation of the papers, and we narrowed down the set to 6 or 5 candidate papers for the 2 awards. In the second round of evaluation, where all committee members looked at all of the remaining papers, of course, except for those where we had a conflict of interest, we narrowed this selection further down to 3 and 3 or 4 for the 2 awards. And third, we had an extensive committee meeting in which we selected 1 winner for both awards anonymously. So please, next slide. So with that, we can already present the winner of the 20 Years InfoVis Test-of-Time Award based on the following reasoning. In their seminal work, the authors helped to set the stage for empirical work to evaluate readability in graph visualization. Based on a set of carefully defined generic tasks, as well as 3x3 synthetic test graphs, they compared an adjacency matrix-based visualization to the omnipresent node link diagram with a spring embedded layout. Finding arguments for both visualization approaches, depending on the task at hand, this work has resulted in long-lasting impact on related visualization research in the last 20 years, comprising an important early milestone upon which a large number of follow-up studies have been conducted. Next slide. So the 20 Years InfoVis Test-of-Time Award goes to the 2004 InfoVis paper, A Comparison of the Readability of Graphs Using Node Link and Matrix-Based Representations by Mohammad Ghoniem, Jean-Daniel Fekete, and Philippe Castagliola. And Mohammad is with us to accept the award and say a few words. Please, Mohammad.
It is such a pleasure and a great honor to receive this prestigious award. On behalf of my co-authors, Jean-Daniel Fekete and Philippe Castagliola, I would like to thank the Test-of-Time Award Selection Committee for this distinction and the VIS community for their continued interest in this line of work over the past 20 years. Next, please. In the early 2000s, the graph drawing community was mainly focusing on node link diagrams. Our paper broke the statu quo by introducing adjacency matrices as a viable alternative. The stimuli we see on this slide correspond to a mildly dense network with 50 nodes and 400 links. Next, please. The results of our controlled experiment showed that node link layouts are preferable only for small sparse graphs, while matrices are better for large and dense graphs for most tasks. We also found that node link layouts and matrices were equally poor for pathfinding in large and dense graphs. Next, please. In reality, there are many contexts in which very dense, almost complete graphs can be encountered. Jean-Daniel and I were part of a project building tools for explainable algorithms to solve constraint satisfaction problems, where such dense graphs are common. Coming from a mathematics and engineering background, matrices seem to me just as legit and natural as node link diagrams to represent a graph. I was visiting Jean-Daniel during his visiting professorship at the University of Maryland when I made a joke about displaying a matrix instead of a node link diagram to avoid edge clutter. He embraced the idea immediately and we set sail to a new adventure. I believe that PhD candidates need a safe and challenging space to thrive, and Jean-Daniel provided me with that. I like to think of him as my doctoral father, as our German colleagues put it. Visualization research is a demanding multidisciplinary field. It often takes a team to achieve impactful results and put up a good fight against disbelief. We were lucky to get help from colleagues such as our co-author Philippe Castagliola for the statistical analysis, Véronique Liberati, an HCI researcher at the French Post, for the study design, and also from my then office mate, Pierre Dragicevic, for implementation aspects. We are also grateful to Catherine Plaisant and Ben Schneiderman at the University of Maryland for hosting me twice as a visiting student. Next, please. We feel blessed by the attention of the VIS community. The follow-up work includes extensions of matrix representations, matrix reordering algorithms, and many application papers from other communities as well. More importantly, we realized as a community that there are other representations of networks than classic link node link diagrams, including quilts, biofabrics, and orderable node link layouts. Next, please. To conclude, we would like to remind our colleagues, especially the younger ones, to be proud of their work and to be proud of belonging to a vibrant community that recognizes good work. We would like to call on our community to promote visual literacy through teaching. This is the only way for matrices and other advanced visualizations to find their way into commercial products and popular data visualization suites. Next, please. Giving love back to our community, we are organizing the EuroVis conference next year in Luxembourg. Please join the fun. Thank you.
Thank you, Mohammad, for this great honor and nice award for this amazing work. Next, we give out the 10 years InfoVis Test-of-Time Award based on the following reasoning. So 10 years ago, the authors contributed their work to the community, spawning an extraordinary run of success. Their approach to represent sets, their intersections, and their aggregations in a smart tabular layout paired with highly effective interaction mechanisms included means to sort and query the data, got highly appreciated on an impressive scale, also far beyond the realm of visualization research. Importantly, also supported and facilitated by the author's approach to open science and reproducibility. This work is one of the very few with a large 4-digit number of citations, of which a large share is found in other fields of science, making use of it for data visualization. Besides being a wonderful showcase of highly successful visualization, this work also takes an important place, emphasizing the role and potential of interaction in visualization. Next slide. So the 10 years InfoVis Test-of-Time Award goes to the 2014 paper Upset, Visualization of Intersecting Sets by Lex, Niels Galenborg, Hendrik Strobelt, Romain Villemont, and Hans-Peter Pfister. So Alex is with us to accept the award. Please, Alex, take the stage.
Thank you, Helvig. Thank you so much. Next slide, please. So I want to thank the community, the committee, and especially my co-authors for making this a great paper and having it received so wonderfully. I want to reflect a little bit on how Upset Plot came to be first, and then a little bit about what made it successful. Maybe some of these things kind of like apply to your next project. Next slide, please. So this whole thing started out on Twitter. I at one point saw this particular infamous banana Venn diagram, and I was upset at that point about it. And I was thinking about how can we do this better. And I found some inspiration by, for example, Robert Cassara, but there wasn't really like a great tool out there for like simple set visualization. Next slide, please. So I sat down one day and sketched in my notebook, and this is what you can see here. And the wonderful thing about this is that this is really like very much a representation of Upset as it later was implemented. So like the first sketch very much already resembled the result. And then I also wanted to implement this in D3, which was like new to me at that point. I only had done Java. And this here is like the first prototype that I developed. But at that point, I realized that this is like too big of a project. It was also like late December of 2013, and I wanted to like get this done for InfoVis, and so I assembled a dream team. Next slide, please. And this is really like the thing that stands out about this project. It was like a unique set of authors, like Niels Galenborg, Hendrik Strobel, Romain Villemont, and Hans-Peter Pfister. And there's a few things that are like special about this paper. These were all my friends at the time. They were all postdocs at Harvard. We just had a great time. We were all experienced visualization researchers already, to some degree at least, but we also didn't have kind of like the constraints of being faculty. And so we really had time to sit down and think about this and work on this like with an extreme pace for like 3 months straight. Next slide, please. And so we eventually came up with this very cool looking interactive visualization technique. This is the teaser from the paper back then. I'm not going to explain how it works. If you're interested, there's like lots of resources online about how it works. Next slide, please. So why did Upset become so successful? There's a few points that I want to make. So first, next slide, please. Upset really solved a real pressing need. It turns out the banana Venn diagram was not an isolated incident. There are many others like similar figures in the biomedical literature around that time. They were frequently used to kind of compare shared number of genes between species. And so clearly there was like a need to do this efficiently. These charts just don't do anything useful with data visualization. Next slide, please. The other thing that I think eventually made Upset very successful is that we met the users where they are. We built first this interactive version that we felt we needed to build for a visualization conference, but then we also thought about how can we actually make this more accessible to the biomedical community. And so Niels led the implementation of an R version that integrated upset plot in these kinds of users' current workflows. So instead of having to upload their data set to a web tool and then take a screenshot that they have to clean up, we really made it easy for them to create those figures. And we also emphasized outreach to the biomedical community. We wrote a short applications note paper. We wrote tutorial-style articles in Nature Methods. We also have explanatory websites and even a Wikipedia article. Next slide, please. The other thing that is noticeable about the system is that the idea is more impactful than the system. So the upset idea has been re-implemented at least 13 times in different programming languages. That's of course great because now it's available in all kinds of workflows, but it's also great because we don't actually have to maintain this code and fix the bugs of the people that are using it. Next slide, please. And then one thing that also helped, I'm sure, with the popularity of upset is that it's useful for communication and discovery. Niels in particular always mentioned that discovery-focused visualization often doesn't get the credit it deserves for the part they play in a scientific process because people use it to find something, but then maybe later use statistical method to validate what they saw in a visualization. The good thing about upset is that it that is useful for discovery, but also for communication. And so you can really create a figure that is readable. You can include it in just like it comes out of, for example, one of the Python and R packages. And I'm sure that helped a lot. Next slide, please. And I just want to note that we are still working on this. So here's a version of upset that we call upset 2. You can go to upset.multinet.app and play with it. You can upload your own data. You even get text description for blind and low vision users. And there's many other interesting things about it. So thank you again to my co-authors and thanks again to the community. It's a great honor.
Well, a lot of congratulations to the wonderful papers and award winners, and this moves us on to the VAST Awards, I think.
Hello, this is on the VAST 10-year Test of Time Award. My name is Tobias Schreck of TU Graz. Next slide, please. And we are glad to present this award on behalf of the committee comprising David Ebert, Giuseppe Santucci, Jing Yang, and myself. Next slide, please. To the process, the committee received a candidate list of 15 VAST papers of 2014 and citation statistics from the steering committee. We started by first documenting conflicts of interest co-authors and advisee conflicts, which were given for Tobias Schreck and Giuseppe Santucci. Conflicted members did not discuss and vote on respective candidates. The committee then, in a first offline phase, then an online phase, discussed the candidate papers and criteria, mainly lasting impact, impact across domains, and quality and presentation of the work. After that, the members voted by sending one nomination to the chair, and the chair did not vote due to conflict, as mentioned above. Next slide, please. The committee anonymously voted for a paper that is a reference model for the knowledge generation process in visual data analysis. It's an elegant, expressive, and well-grounded model that references existing previous works, theories, models, goes beyond it. It shows large numbers of citations constantly across the last 10 years, and it has been picked up, cited, used, applied in many areas, including applications, design studies, interaction and workflows. Surveys has been used in frameworks, and stands the time of test, the test of time for filling a gap in modeling the visual data analysis process. Next slide, please. So the award goes to Knowledge Generation Model for Visual Analytics, authored by Dominik Sacher, Andreas Stoffel, Florian Stoffel, Umchul Kwon, Geoffrey Ellis, and Daniel Keim. And Dominik and Bumchul BC are with us to give the presentation.
Yeah, thanks a lot, Tobias. And hello, everybody from my side. We feel, of course, very honored to receive the award. And we want to take the opportunity here to reveal a bit of the process behind the creation of the process model. So one thing that we really want to emphasize that the key driver for creating the model have been always the discussions about it. And if we go to the next slide, for example, you see now that in the early stages, we had a lot of discussions in the VIS group, and we created a lot of different versions of boxes and connecting boxes. And also, if we do the next animation now, the major feedback that we always received was that it looks too structured in this way, and that the human process should be illustrated in a different way. And if we go to the next slide, that was the main reason why we came up with the loops, in order to show that there are a lot of related processes happening at the same time and influencing each other, and also that there are different processes between the computer and the human process. If we go to the next slide, the second step was also then to took this in a bigger picture. And if we now take the next animation, you see the left-hand side, which is more the technical processes where we combine the InfoVis pipeline together, for example, with the KDD process. We also have the other processes, which we are now at the next animation of the human processes, something like the sense-making loop, which we further broke down into the exploration, verification, and knowledge generation loop. And with that part, I want to hand over from my perspective to BC.
Yeah, thanks. This paper is really, really special to all of us, especially to me. It was my first project I worked on with the IEEE Constance team during my postdoc, first time shaping theories on visualization design. I still remember drawing, erasing, redrawing these diagrams all together on the board together with the team. And that process actually gave us opportunities to refine our views and perspectives on visual analytics designs. And can you go to the next slides? Oh, one thing to note is this paper received quite a range of scores, so 2 to 5 or something like that, showing a wide spread, and the comments were really intense regardless of the discussion, direction. And I think this intensity was a positive sign because it indicates that people are engaged and want to discuss the topic and methods and takeaways. So thankfully, the paper actually received a lot of citations. And next slide, please. Next animation, please. This work became foundation for many future projects like surveys. And next slide, please. Next animation, sorry. Application, designs, and next animation, please. And evaluation and further deriving the refinements of the models. And I still use the model diagram in almost every presentation to explain my research in the field. And the languages that we developed in the picture and design abstract actually continues to shape my thinking and work today. Can you go to the next slide? Special thanks to Daniel Keim, who provided guidance and coordinate the efforts. And we're grateful to our teammates, reviewers, and everyone who helped make this possible. And we hope this research keeps inspiring new projects that improve how we capture design ideas, visualize data, build tools, and solve problems. And thanks for the committee as well.
Very good. Congratulations to all awardees. I give back to Ross.
Great. Another big round of congratulations to all of our award winners. And with that, we can adjourn this session and let everybody head off to the capstone. Thank you all and congratulations again. Great work.